we'll start with a few words from his side. So enjoy.
Yeah, thank you. So my name is Josef Dahl. I'm in the business development department here at SAP Switzerland for topics analytics. And for SAP, it's important predictive analytics, machine learning, all these topics are really very strategic for SAP and our collaboration with our customers in this field. And to scale also, we collaborate very, very tight with partners, and in this case for Switzerland also with Swisscom. That's the reason we as a common sponsorship do this together, and we take examples out of that we have together with Swisscom to present you here. And so I'm happy to have Matthias here for the presentation. And, yeah.
Thank you, Günther. So, as I said, my name is Matthias Mohler. I'm working for Swisscom, not for SAP as it says here, but as Günther said, we're close partners. I'm leading the team for SAP Business Objects and also predictive analytics. I'm going to show you a little bit more about our journey in that area. Let's have a look at the agenda. First, quick management summary, so you have a little idea about what we are doing there. Then about Swisscom, so that's often quite interesting because a lot of people know Swisscom from the private sector, but we do much more, so we'll give you a little idea about where we are working on in the area of IT and predictive analytics detail. Then we will have a look to our approach in predictive analytics projects that we usually take. The architecture, which is of course also based on SAP technology, and we are an SAP partner. It's quite important there to see what kind of capabilities, technical possibilities we leverage in order to perform our projects. Then I'm going to show you 3 concrete use cases. One is about dunning prevention, another one about banking, you see, together with a bank. And the third one is about carrier building, that's how it is called. We'll tell you more details later. I need to add one disclaimer though, my predecessors were very technical, so you will not be able to ask me any questions about algorithms. I cannot answer them, most probably. But we will set the focus on the business cases here, and also on the technical infrastructure and the automation of those cases, because that's what we stand for and where we try to get into. And of course, also we gained a lot of lessons learned in the last couple of months and years from those projects, and I would like to share with you those insights. And then we will have some time for Q&A. Abstract is clear, I guess, from foundation perspective and from the results we gained. And as I said, we're coming from the traditional SAP BI business, so we're implementing business intelligence solutions. And on customer side, we increasingly recognized that in addition to the analytical functions we were implementing, data warehousing and BI, we increasingly see potential for smarter functions, predictions and trends and pattern recognitions, which require, of course, a bigger knowledge in statistical or in applying statistics on data. Therefore, we started to conduct some POCs coming from that SAP Business position into the area of predictive analytics using SAP predictive analytics software. So we did that in the recent years, I would say 2 to 3 years, and we had a couple of POCs we were able to conduct. That gave us a lot of insights and also possibility to learn about the approach we want to take there, and to be able to convince customers of the huge value that it can generate with predictive analytics in addition to traditional BI. So, quickly about Swisscom. I said I could do it like that, more than telco. It's really much more, but just within our area, digital enterprise services, we are responsible for basically all digital needs that corporate customers may have. This can start with classical telecom services like mobile or fixed net solutions, standardized or individual, but goes over server hosting till what we do, planning and implementation of SAP solutions. Yeah. And that's of course across the whole life cycle, design, build, and run. So we concept systems, we implement, develop them, and we run them for the customers in several modes. That gives us a very good sort of foundation also to go in talks with the clients, because we see their processes, we see how they work, and we know their systems because we most probably build them or host them. Yeah. We know their data quite well. What is our value proposition in that topic? As I said initially, we are not really data scientists, or many of us are not. There's a colleague from my team, Sergio, he is one, but most of my colleagues are not. So what is our value proposition? Basically, we say we're coming from the business process area, because we have implemented ERP systems since long years. Therefore, we know the data very well, we know the processes, we know what are the needs of the customers in those processes. For example, logistics or finance, marketing, and we have the customer contacts. Therefore, also, it gives us a very nice possibility to identify those business cases, because we're in frequent touch with the customers, we know their needs, we know their data. With that combination, we can try to propose such new kind of solutions, which is, of course, much harder if you start to do that in sort of a siloed way with a customer that we absolutely don't know. Exactly. Again, so most of us are not data scientists. We're really coming from the ERP, business intelligence corner, but we see increasingly that demand and the potential, and we try to push it from this. So what is the architecture we apply in the area of predictive analytics? As I said, we are very interested in using the software of SAP, because we're SAP partner. There is a client which is called SAP Predictive Analytics, which is a fat client software you can have on your PC, which is capable of accessing data in many ways. Filed, of course, any kind of database you can access via JDBC or ODBC. Hadoop and those kind of systems, right? And also, this is very interesting, SAP HANA, when SAP ERP, the business system, is running on HANA. Why is this so interesting without making advertisement? I think that's a very interesting point, because I can build models here in the client, and I can deploy them here to be run in memory continuously. That's very interesting, because usually and traditionally we move data out of those operational systems, and then we perform analysis, and somewhere maybe we partially automate it, and with a delay of a couple of days, a month, we write those scores back to the systems to be used. But the target and the strategy of SAP here now is to bring everything closely together, operational system and analytics. And that's where we see huge potential, because we can run analytics in database and include those results in the operational process, right? Of course, we need to add a disclaimer, right? If you have a huge amount of data, there is also an end, right? We need to be honest. But it is potential that you can really influence your operational process with statistical information right away. You don't need to wait. One example we've been discussing also SAP is when you have to buy a good in the procurement process, and you need to choose a vendor, right? So what could happen? The system could suggest you the vendor that is very likely to deliver because of analysis of the past, right? And that could tell you, yes, he is most probably able to deliver you the goods on time, right? And then you can use that information to move on in your operational purchasing process. It's quite interesting, and it's right away. It's real business activity monitoring. So of course you could also then move the algorithms and the data to the R server and perform analysis there. On the other hand, then you lose that sort of real-time factor. That's important to know. But it's still a possibility you can opt for. There are several libraries you can use. The predictive analysis library, which consists of a set of algorithms you can use. Those are quite standardized. You have input parameters you need to sort of leverage. And there's also the APL, automated predictive library, which is, as I just said, focused on automation in database mining. And of course, if you want to have it very individual, and if you are a data scientist and are very well aware of those kind of algorithms, then you can code everything out using R. Good. So just some impressions. That's how the client looks. It's most, I would say, it's mostly similar to the other tools. We know you can connect to several data sources, and then you have the ability to apply data cleansing, and in the end to choose one or many algorithms, run it on top of it, and then do something with the results. Right? So we see, as I said, two key benefits of that architecture with the use of SAP predictive analytics. One is the automation, and one is the integration. In terms of automation, as I said, it's very interesting to run those models on a recurring basis as much as possible, not just as a one-shot analysis, and have it run in database. And the second point, which is of course very tied to the first one, is the integration to the SAP system. It's very nice that you run your analysis on top of operational ERP data, and that the same vendor can offer you also technical capabilities to access that data in a very nice way, and that will also evolve. So you have good interfaces to the data that you can make use of, and it's very time integrated. It gives you, as I said, in the end, the possibility to use those results right away in the process. And that's where it is going on the mid and on the long run. Now, our approach to undertake such kind of projects is very focused, as I said, on the business value. First of all, in step one, we try to get clarity on a certain use case. We try to understand the process and the scope. We try to collect sample data, to understand the data, to assess what is there, what is available, what quality we have, what quantity we have. Then we prepare the data, which is of course huge effort, as we found out, and I think many of you would confirm that, and perform the analysis. And in the end, point 4, most important, within such kind of a project, which we do as a POC mode, the target is not really to build a very nice function, a very perfect model. The target is really to approach the business and define a business case for automation. So we start with maybe 20, 25 days, we go through that cycle, and we try really to establish a situation where we can convince the client of a business case. And that's the most important point in this process. And in the end, of course, the pain will come that we have to implement this in the operational architecture and make sure that we can establish those algorithms to be run on a recurring basis within the system. So now I'm going to the 3 POCs that we did, and I'm starting with this dunning prevention case. So first of all, as an overview, of course, as I said, Swisscom is also a telecom company, and we offer services to customers, to retail customers, and of course, we send a bill to them. So most of the customers pay the bill, and some they don't. What happens if they don't send the bill? If they don't pay the bill, they receive the dunning letter, where we ask them, please pay the bill. So there's a period between sending the letter and receiving the letter. And in between there is something we call cross-payers. Those guys, they pay the bill because they're not aware of that they got the dunning letter. They would receive it, but they pay. So in conclusion, we shouldn't have sent them a dunning letter because they would pay anyway. So what business case comes out of that? How can we predict which customers will pay anyway, so we don't have to waste money for sending them a dunning letter? And it sounds like not a nice business case because the letter costs 1 franc, but if you are Swisscom or if you're a big insurance, you're sending like millions of letters to your customers, so suddenly it becomes interesting to do. So the idea is to eliminate this for those customers that are very likely to pay in between. What is the result of that analysis in the project? We were able to predict 88% of the cases that did indeed pay, so we could have saved the money of sending them the bill because they were paying anyway. Of course, that's also something we need to aware of. 12% is not covered, yeah, so we need to consider that. And also on the other hand, there's false positive cases, right, where you would then send no letter, but they would anyway not pay. So in those cases you need to handle and be sure that this is covered in the business case, but it still can be worth to the data. And what we calculated when we extrapolated it a little bit over the year is that we could save 600,000 Swiss francs if we cover that target group and stop sending them the dunning letter, because we know they would pay. So how did we do that from architecture perspective? First of all, we had those billing tables in SAP ERP, RMCA payments. And we had some flat files, and it's important to mention for the POC, our target is not automation. Our target is to prove the business case. Later, we will try to make this more integrated into the operational system, as we said in the beginning, in order to leverage the benefits of the SAP predictive analytics. So what we then did, basically we loaded the data into SAP HANA and did build, use. Those are sort of a little bit more semantic, clever database use, where we had the chance to cleanse the data in a way we needed it for the model, to aggregate it on the right level. And right away when you access those views, it will do those steps again, right? So you don't need to do this all the time when you run the analysis. That's a quite important step also with regards to automation, and to make sure that later, when we want to automate, we can reuse those artifacts because they help us within the data cleansing process. And in the end, of course, we put the predictive analysis client on top of it to build the algorithm and to learn the model and run the analysis and generate the scores. Second one, also very interesting, we did it with a Swiss bank. I think it's 1 year ago, approximately. The scenario is as follows. There's a bank, there's a mortgage, and there's a customer. So the customer needs the mortgage to pay his property or to own his property. It could be that at one day he is quitting the current mortgage because the conditions are not nice anymore and he's got offering some better conditions with another bank offering a mortgage to this customer. So the question for the bank, for this bank, is how can we find out which of those customers are very likely to churn, so to leave, so that they can make them a retention offer, which is of course costly, but it could be still less costly than losing all of the customers. And that's the business case at the end. So the result would be in that case that we calculated a risk score between 0 and 1, which 1 is of low risk, 0 is of low risk, and 1 is of high risk, and to be able to suggest a next best activity to the client, client advisor, so the person who's taking care of the client, in order to be able to sort of propose to the customer either a better contract or a prolongation of different conditions. Yeah? So as I said, the business case in this scenario would be to look at the cost you have with making those retention offers, because you may give a discount to the customer, and the cost of those discounts for that group should of course be less than the cost of losing all customers to the competitor. Also here, it's very vital and very important to take care on the false positives, because you don't want to offer discounts to customers that anyway are not likely to churn, right? And that's the challenge here. But that's also mainly or first and foremost a question of how the business wants to use those results, and less about legalities behind. That's an insight. Regarding the architecture, that's a quite interesting one. So of course it's always challenging with banks because they have everything in their own house, they have their servers. So how we did it that way, for the POC they were using SaaS and they were exporting on a regular basis the files to an FTP server with SAP data services, that's an EDL tool. we were collecting the files and sort of loading them to SAP HANA. And on top of that, it's exactly the same process we did in the previous case. We cleanse the data within the view so that when you consume the view, it will perform those cleansing steps and then run the analysis on top of it with predictive analytics. Last case. That's a very interesting one. That's also within Swisscom itself. So we have a service which is called Natel Pay. So when you have your phone, you can download an app, and within that app you can make in-app purchases, right? And now what the colleagues observed in that area is very interesting. There are a couple of customers. They are alone at home in the evening, and they're bored. They're starting to play Candy Crush. This is a game you can play on your phone. And then they play themselves in sort of a rush and buy a lot of sort of in-app purchases, right? And in the end, they have a huge bill, which they are, of course, unable to pay. So it's a little bit similar to the first one, but a little bit different scenario. So what happens in that case? They order that service and they charge it to Swisscom's bill, and Swisscom pays the money to this vendor, for example, Apple or Google or anybody who is offering any kind of e-service over the phone that you can charge to your phone bill. So in the end of the month, Swisscom is sending a regular bill to the customer, of which one position or many positions would be of this service. And those are huge positions in those cases, and the customer cannot pay it. So we have chargeback cases. And that leads to the fact that we have a huge debt there, and we cannot get the money from the client, and we need to pay it, in fact. So we want to avoid it and try to find out which clients, based on our data, are very likely to be such cases. So we can identify them, and also in the scenario of sort of a business activity monitoring, implement an automated process where we can reduce the limit, the spending limit of those people to a certain extent, so that they are not able anymore to spend like thousands of Swiss francs. On the other hand, also here we need to be quite sensitive, because we could also reduce the limit for customers which are very able to pay, and we don't want to make them angry. So dealing with the false positives, again, very important. We are still in the process of that POC, so we haven't any results, and we haven't calculated the business case. But the idea should indeed be that, that we are able to save money with setting that limit to certain customers without reducing the limit for so many customers that we're making less revenue, because we're sort of reducing the customers that can pay it. So that's the challenge there. And we're really curious to see whether we can identify the variables and drivers that are sort of responsible for those kind of scenarios. Regarding architecture, it's a little bit different in this case. We get the data from billing from the systems. So it's basically from the source system automatically delivered to the data warehouse already. This is a non-SAP data warehouse. So it's also interesting for us to work with other technologies there than we were basically used to. It's a Teradata data warehouse. Nevertheless, it's also interesting in terms of automation, because the whole data loading process is, of course, industrialized and automized, and we can just pick up the model, and if we have the business case, and if we define with the business whether we want to implement it or not on a recurring basis, then we can run that model and implement it continuously, monitor it, and refine. That's the idea. What are the lessons learned so far? I would say we have many takeaways, but I try to summarize the most important three. Many of you know that, I'm aware. Yes, data preparation is 80% of the work. That's also very clear when you're coming from traditional data warehousing. It's most of our business is not presentation or analysis. It's simply bringing the data in the right shape. And that's undoubtedly the most important step in this process as well. Then what we observed as very important, or even more important than in classical data warehouse projects, is this frequent interaction with the business, because we saw we were very much relying on that business and domain knowledge, because it's complex and we need to be very clear about every variable, about the shape. We need to discuss what do we do with missing values, what quantity of data we need. So we need to be very close to the business in those cases, and that's one learning we had from those QCs. And the third one, we think based on our experience now, partial automation is possible if you have simple cases, if you have a tool like SAP predictive analysis that is indeed focused on automation, on integration with operational data. But also we think in very complex cases it's still very much needed to have statistical professionals and data scientist professionals to work on the complex models and to refine them. We think this is sort of a half-half thing. We think that in the future more and more operational processes will be enhanced with statistical functions, but that doesn't replace the current stack of data science projects and individual analysis that needs to be done. I think it's a very valuable addition. And yes, we are still excited to move on. We think it has huge potential. And yes, we're looking for the next big project there. Maybe some words about automation, because I was talking a lot about automation, the whole process. I want to also share with you some insights we gained, because that was our target, to try to automate as much as possible, or to think how to automate the whole process. Useful is the selection or the recommendation of the selection of the model that SAP predictive analysis is offering. Of course, also here, I think if you are very specialized and if you are very well accommodated to those tools and very knowledgeable in statistics, then this might be not for you. Then you are better using the libraries, you're using R, because you know what you do, and you can be much more accurate in what you do. But for the quick business cases, for establishing business use cases, this was a quite useful feature for us, indeed. So also very interesting is the generation of many specific models. For example, if you build a model for sales stores all over Switzerland, and then you find out that for certain sales stores, there are completely different conditions. If you look to the data, for example, because of different population demographics and so on and so forth, so you have the possibility there to generate automatically many models without doing it manually. But of course, also here, some refinement is needed. That's also something we need to admit. So when you generate it, then you need to also look into it, refine it, and accommodate to local conditions to make sure that really the output is what you expect. Finally, also, we must say continuous monitoring is needed. It's not just like a normal BI function. Even there, if you have an ETL stream, you need to monitor it. It's just not self-running, right? That's something we need to admit. And of course, then retraining is needed if the data is substantially changing. It's actually quite important insight. Good. I would be at the end. Are there any questions? I see already there are.
Thank you very much.